Chapter 8, Section 3, Tests for Parallelograms. That's where we're at today, folks. So what we're going to be looking at today is something a little bit different from yesterday. Still parallelograms, but we're going to do some mental gymnastics in that. Here's the deal. We were looking at this idea of we have a parallelogram, right? So like our if statements with some of the proofs and things we did on our last lesson. And then because of that, we were able to then prove different ideas that we had about our parallelogram, right? Today, though, what if we don't know about this figure? What if we don't know that it's actually a parallelogram? And that's going to be the difference. Today, our if situations are going to be these ideas that we have about our figure, and our ultimate goal, our then statement, is going to be whether or not this is a parallelogram or not. All right, so we're going to be looking at converses. All right, everything we did in our last unit, we're basically going to turn, or last lesson rather, we're going to turn it on its head. And instead of starting with a parallelogram and ending up with some interesting concept or idea, we're going to start with some ideas and see, do those help us figure out if we have a parallelogram or not? So the theorems that we're about to look at today should look vaguely familiar, simply because they're going to be the reverse of what we saw in the last lesson. So let's run through them real quick. We'll see if we can prove them in a sort of impromptu way. Nothing very formal, very informal here, and see what we can do. So our first one, if both pairs of opposite sides of a quadrilateral are congruent, so in other words, if these two sides are the same and these two sides are the same, then the quadrilateral is a parallelogram. Awesome. Well, remember, in order for it to be a parallelogram, there's two key ideas we need to look at. First, do we have four sides? 1, 2, 3, 4. All right, we check that box. Second thing we're looking for is, do we have parallel sides? Because remember, by definition, our sides, opposite pairs, have to be parallel. Well, notice I've already got the four side bit figured out. As a matter of fact, for all of these, we've got the four side bit. We were told it's a quadrilateral. So what I'm ultimately needing to prove is that I've got parallel sides. Just keep that in mind. So the first thing I'm going to do is I'm going to draw a diagonal in, and now I've got two triangles. And notice these sides match up, these sides match up, and of course the third side matches up. Now I want to show you something. This angle here and this angle here, sure enough, are the same by CP, CTC. Corresponding parts of congruent triangles are congruent. Notice that by definition they are alternate interior angles. They are also congruent alternate interior angles. So we can use our converse of the alternate interior angles theorem to show that our top and bottom lines here are parallel. Cool. All right, well, let's do it again. We can look at this angle and complementary with this angle. So now our two sides, we have alternate interior angles, and by the converse of the alternate interior angles, since they are the same, then wonderful. That means these sides are also parallel. Cool. Quick and easy proof of what we've got there. Again, very informal, but quick and easy. All right, let's try this next one. If both pairs of opposite angles of a quadrilateral are congruent, so notice this angle and the angle opposite it are the same, this angle opposite of it are the same. Cool. So if they are congruent, then the quadrilateral is a parallelogram. So remember, what we're trying to do is to show that we ultimately have four sides, cool, that works, and that we ultimately have parallel side lengths here. So we got the four side bit down, 1, 2, 3, 4. Now we need the parallel part. All right, let's see what we can manage here. Well, notice I can take this and we'll draw in a diagonal. And let's see if we can prove that we have two congruent triangles. Right? So notice they have a angle in common, so that's good. We've got a side in common, that works. So the question is, what other information do we need in order to make this work out? So one way to do it is see, do we have another side or another set of angles that we could work and see if we can make that happen. One thing I'm noticing is that it doesn't work so well. I don't have those sides that I would need, and trying to work those angles out could be a bit of a trick. So let's try it this way. Okay? Instead, let's make this angle worth x. So we've got an x here. And let's let this angle be y, again, just to give it a name. And let's try something else. We know since it's a quadrilateral that it will add up to 360 degrees. Cool. And if I add all of these up, we would get 2 x's and 2 y's. If I divide that out, I get x and y is 180. So in other words, let me ignore these and let me take a look at those. And I notice that these are consecutive interior angles. And I notice that not only are they consecutive interior angles, but they are supplementary consecutive interior angles. So I can say by the converse of the consecutive interior angles theorem that this side and this side, lo and behold, are parallel. Since this is also worth y, we could do the same trick again over here and show that this side and this side as well, also parallel. So notice, sometimes we'll use 2 triangles. Sometimes we'll use what we know about our parallel sides and use the converses there, right? Both methods work well. All right, let's try another one. If the diagonals of a quadrilateral bisect each other, so notice this side here has been cut in half, this one here also cut in half, then the quadrilateral is a parallelogram. Wonderful. Well, let's try something. I noticed that we've got 2 triangles here. We'll go with top and bottom. These sides match up. These sides match up. We just need an angle. Well, notice the angle here and angle right below it are vertical. So by side angle side, we've got 2 congruent triangles. And then by CPCTC, I can say that this angle here and this angle here are congruent. Notice they're alternate interior, which means, ta-da, we have parallel sides. And then we could do the same trick with these 2 triangles. We could prove, say, for example, this angle here and this angle over here, which would then show that, hey, we've got parallel sides here as well. So wonderful. Again, as long as we can find that parallel bit, we're doing well. Now this one's different, all right? So you might make yourself a line here. The others seem relatively familiar, things that we've kind of dealt with before. This one is an odd duck, all right? Now take a look. If one pair, notice one, I'm going to highlight, underline, circle that, whatever, one pair, just one pair of opposite sides of a quadrilateral are both parallel and congruent. So it's got to be both. So no fair just being parallel, no fair just being congruent. It has to be both. Then the quadrilateral is indeed a parallelogram. Cool. All right, so how would we go about proving that? Right? What could we do or say to make that work out? Well, let's try a couple of things. One way we said that we've been proving these is to break it up into 2 triangles. So let's try that real quick. So if I were to divide it, and we'll maybe do that diagonal here, I notice that they have a side in common. I notice also that this would be a transversal, so to speak. So this angle here and this angle here would match up. I also notice that they share this side in common. So it looks like we've got side, angle, side. Side, angle, side. Well, cool. If that means our 2 triangles are congruent, then that means their parts are as well. So this side and this side. And notice we could go back then to our top theorem. If we have both pairs of opposite sides being congruent, then cool, it's automatically a parallelogram. So excellent. We were able to work that one out pretty straightforward and easy. So to summarize, that's a lot of information. Let's go to this. Here's how we know if we've got a parallelogram or not. First one, both pairs of opposite sides are parallel. We know that by definition. So if you can figure that out, then cool. By definition, it's a parallelogram. And notice, that's pretty much how I solved most of these, not the bottom one, but these I was able to prove that I had opposite pairs of parallel sides. Cool. That means by definition, it has to be a parallelogram. So that's one way to do it. All right. Both pairs of opposite sides being congruent. Cool, that's what this is. So a theorem. Both pairs of opposite angles being congruent. Cool, that's this. It's a theorem. Diagonals bisect each other. What do you know? Another theorem. And then a pair of opposite sides is both parallel and congruent. Again, if we can show that, then wonderful. We know we've got a parallelogram. So those are all the different tests that we have to show well, is this quadrilateral a parallelogram or is it something else? Right? So let's do some examples. Let's get some of the work done here and see what we can do. Determine whether each quadrilateral is a parallelogram or not, and then we have to justify our answers. So let's do these kind of quickly. Notice I've got opposite angles being congruent. So that's my reasoning for saying 100% yes, that's a parallelogram. Looks good. All right, let's try another one. This one, notice 4 sides. That looks nice. We've got our diagonals drawn in. This diagonal's been cut in half. This diagonal's been cut in half. So I can say yes, if I have a quadrilateral whose diagonals bisect each other, it's automatically a parallelogram. That looks good. Let's take a look here. Opposite angles being the same. So cool, same as what we have here. If I add up the 25 and the 155, I also get supplementary angles, so we know that those are parallel. Supplementary angles parallel. So yep, definitely. Now notice this one. This tells me that 2 of these are congruent. Wonderful, but it doesn't tell me anything about them being parallel. So without any more information, I'm gonna have to say no, probably not a parallelogram. All right, let's try this one. One pair of opposite sides being both congruent and parallel. We said that works, so we're good. All right, let's see what we've got here. In this case, I know one pair of opposite sides is congruent, but we just said that that in and of itself is not enough. I also noticed that one of the diagonals has been cut, but again, don't know about the other. And even if this vertical angle plays out for me, that's a side-side angle scenario, and we know that that doesn't lead us down a path we want to go. So in this case, probably not, unless we've got some more information. It very well could be, but based on what we've got at this point, probably not. All right, let's try some others. All right, in this case, we got to find x and y so that each quadrilateral is indeed a parallelogram. So for example, in this case, I've got 2x on one side, 5x subtract 18 on the other. If this was a true blue parallelogram, then these two would be the same. So I could set up something like 5x subtract 18 equals 2x, and then of course we could solve from there. So we can subtract the 2x on each side, that's 3x. Go ahead and add 18 to both sides. There's 18, divide by 3, x is 6. Now obviously we could do a similar trick there with y, set these two sides equal. I'll leave you to do that. Let's try this middle one. Notice we've got our diagonals drawn in, and in order for this to be a parallelogram, we know that they would have to bisect each other. So for example, this 5x would have to equal the other side of 2x add 3. Or if we're looking at the y's, 8y subtract 36 would need to equal the 4y on the other side. And again, we could solve both of those equations relatively quickly and find our answers. So in this case, we could subtract 2 from both sides, 2x that is, for 3x equals 3, or in this case, x equals 1. Cool, that was easy. Down here, we could do the same thing, subtract 4y, so that's 4y equals, go ahead and add 36, divide by 4. Y in this case is 9. And again, we're just using that same idea of we've got our diagonals, they bisect each other, setting up our equations, not a deal. This problem works pretty much the same as this one, so I'm not going to spend time doing that. But again, we would set opposite sides being equal to each other, and we could go from there. Notice, though, with this one, we've got x's and y's together, so we would have to solve one of these, say, for y, and then help plug it in for the other. So, for example, with this top one here, I could say that y plus 2x equals 4, or that y equals negative 2x plus 4. Once I know that y, I could plug it in here and then solve for x, and then we can go from there. But again, I'll leave things like that to you. Those are very basic algebra issues, not really worth our time. One other issue, though, that is more worth our time is this. All right, we've kind of dabbled in this a little bit this year, but that's this idea of coordinate geometry, where we're given coordinates and we're looking for distances, slopes, that kind of thing. And we're going to kind of revisit that here. So what we're going to do is we're going to determine what sort of figure we have based on what we've been given. So we're going to look at slopes, probably going to try and see if our slopes are opposite reciprocals or if they're the same to determine parallel or perpendicular issues, that kind of thing. Distances, remember those opposite sides being congruent. Or midpoints, in that case, probably looking at our diagonals, seeing if they do cut each other in half. So let's try this one, number 25. B is at -6, that's over here, -3. So there's B. C is at 2, -3, so that's down here, so that's C. E is at 4, 4, so that's up here, E. And then what's our last one there? G is at -4, 4, so that's G. So we'll kind of draw in our quadrilateral here. And again, you don't have to draw it in. You could just find the distances or the slopes or whatever it is on your own, but sometimes it's nice to have a diagram. So notice this time they want the slope formula. So what we're basically trying to figure out is, do we have parallel sides? Well, I noticed that this slope here and this slope here are zeros, so those match up. And then for the slope here, I'm going up 3, 4, so that makes 7 and over 2. So slope is 7 over 2 for this side. And then up, let's see, 3, 4, over, let's see, did I plot that point right? Nope, I didn't. I went 1 too far over. Thought I did. There we go. That's C. Thought it looked a little wonky. So let's see here. Let's recount that. Up 3, 4, that's 7, and over 2. Yes, indeed. So 7 over 2, and then, of course, zeros. Yep, by the slope formula, we definitely have a parallelogram. Now, obviously, if that wasn't the correct spot, then we would have a slope that was off. In this case, it would be 7 over 1. Those two don't match, therefore not a parallelogram. But again, that's what you're going to do. Either draw it out or just use the points as you have them. Use the slope formula, the distance formula, or midpoint formula to figure out what we've got, and does that match up. All right, if you've got any questions or concerns, please ask, folks, when you come to class, and we'll deal with all of those questions when you get here. Have a good day.